So welcome to this session on HTTP2. My name is David Delabassé. I work at Oracle in the Java EE organization. I guess you have already seen that slide. I will talk about future projects, so anything can change in terms of roadmap, API signature, and so on. So the agenda for today, well, it's a session on HTTP2. So I will first spend some time on explaining basically what are the issues of HTTP 1.1. And basically those issues leads to the specification of HTTP2. Then I will explain what HTTP2 is all about. And finally, I will conclude by showing how HTTP2 will arrive in the platform, in Java SE, but also in Java EE. So, why HTTP2? So clearly, I could have called this section around on HTTP 1.1, because there are quite a few issues with HTTP 1.1. So this infographics show some data around what is happening on the internet for every minute. For example, Google, 4 million search every minute. Facebook, almost 2.5 million users share some kind of content, and so on and so on and so on. Most of those things are being done over HTTP, right? So clearly, HTTP is something that we're using through our life. Right now, we are still using HTTP 1.1 in most of the cases. And you have to know that HTTP 1.1 is a very old protocol. It has been standardized in 1999. So 16 years ago. This was Google in 1999. It was still in beta. You see that it was a pretty basic site. At that time, we were using Alta Vista. Anybody remember Alta Vista? Okay, so that means that you are quite old. But at that time, it was really the search engine. Now, it was acquired and so on. Now it has disappeared. That was Apple in 1999. I think they've launched the iPod in 2001, so 2 years later. Amazon in 1999. So one of the things at that time is that when we were having sites were using graphics, but not as today. I mean, Amazon, if you compare Amazon at that time and today, I mean, on the current page, so today you have many pictures and so on. So at that time, graphics were used, but not that often. So we were using graphics and pictures in a very scarce way. And at that time, obviously, there were some visionary people that were already using a lot of graphics. This is Al Gore, the guy who have invented the internet. So it was a visionary guy. It's a joke, but just in case. But he claimed that. So today, if we take a typical website, we obviously have an HTML pages, and that page basically needs a lot of resources. Some style sheets, some JavaScript files, pictures, videos, possibly Flash, and so on. There's a study that says that on average, a typical modern website is using 90 resources. So that's really a lot. So the issue is that we have to basically deliver those resources over HTTP 1.1. So to give you an idea, I took two sites in France. So I took the most used site in France, and I took two examples. The most used site in France is Google. So this is a very specific use case, because Google, so once you go to google.fr, it has only 3 HTTP requests which are done. So basically you transferred, 21 kilobytes. 1 HTML file, 1 pictures, and 1 JavaScript. But this is clearly, I would say, an exception. The most newspaper site in France, lefigaro.fr, 15th most used site in France. If you go to the home page, 140 HTTP requests are needed to transfer almost 3 megabytes. 1 HTML file, 130 pictures, 6 JavaScript files, and 2 CSS files. So that's quite a lot. Now, it's a bit unfair to compare Google to a news site. Because Google, you have a very basic homepage, while a news site, by definition, needs to provide a lot of information on the homepage. It has to be very dynamic and so on. But it gives you some idea. Now, there is an issue. Because at the end of the day, once you have a website, you want that website to be delivered quickly to the users. Those are some data. You have the source at the bottom of the slides. But for example, a study says that if a page takes longer than 4 seconds to load, you will basically lose 20% of your potential users. So that's a lot. Another one, which is more or less the same, but the numbers are different. So almost 60% of the consumer will leave a page that takes longer than 3 seconds to load. So you can argue about the site, but clearly, if a page takes long to download, you will lose users. There's no question about that. A page slowdown of 1 second could cost Amazon up to 1.6 billion in sales a year. So that's really a lot. For Google, slowing search result by less than half seconds, Google could lose up to 8 million search per day. So that means 8 million potential lose for advertisements. So again, that's really a lot. Now you might say, okay, I'm not Google, I'm not Amazon. But at the end of the day, when you develop a web application, you want to provide a decent user experience because you don't want to lose your users. So that's something that you need to keep in mind. Now, one of the issues with HTTP 1.1 is head-of-line blocking. So basically, the spec says that the resources have to be delivered by the server in the order they have been requested by the client. So you request a file, index.html, and that file is using, needs multiple resources. So the client will obviously ask those resources. So it has the style sheet the first style sheet, the second style sheet, and the script. The first style sheet is delivered, but for some reason, the second style sheet takes longer to deliver. So that means that it will basically stall and block the delivery of that script file. So this is an issue. How you can work around that issue? Well, instead of having one, I would say, blocking or blocked connection, your client can have multiple connections. So it's a kind of pseudo-parallelism. So instead of having one connection that you know will block, well, just open multiple connections. So that works. But the issue is that it's a very expensive operation. I mean, the client has to open a TCP socket. So yeah, it works, but it's clearly not an ideal solution. And most of the browsers are putting limitation on how many sockets they can open. I think for most of them, it's up to 6 sockets. So we know that for TCP, since opening a TCP connection is expensive, but once it's open, it's there, so you can use it almost for free. Well, TCP efficiency improves with larger files. So instead of having to transfer a lot of small files, why not put them together and just transfer one file? So this is basically the idea of sprite concatenation. So this is the sprite map of Oracle.com. So I just put a gray background so that you can see it. But so every time in the morning when you drink your coffee, you go to Oracle.com, that file will be automatically downloaded. And basically that file contains more than 60 pictures. So it's one single file, but we download that big file with those 60 pictures, and then on the client side, using some CSS tricks, we can basically cut and get the pictures we want. So for example, let's say that we want to display that Twitter logo. Using CSS, we know exactly how to get that logo. So that works. That is frequently used, but it has some issue. I mean, if you, for example, need to add one pictures in there, well, you need to tweak your sprite maps, you need to tweak your CSS files, and so on. So, yeah, it works, but it's not the ideal solution. And also, let's say that you have a page that only needs that Twitter logo. Well, you need to transfer that complete file and the CSS to use it. So it's a solution, but again, it's not a perfect solution. So we know that we are limited in terms of connection that we can have to a host. But if we want to have multiple connections, well, there is a way to work around that. It's domain sharding. So instead of having one host we connect to, we can have multiple hosts we connect to. So it could be logical host. So we just do a tweaks on the host name. So that will basically lift the limitation that the client has in terms of simultaneous connections. There is no limitation. So it works. The issue is that on the backend side, you have to basically manage your asset to make sure that everything is handled correctly. So from a content management point of view, it's a bit trickier. And also, at the end of the day, you also need to take in consideration the DNS resolution cost. Another issue, another workaround that is sometimes used with HTTP 1.1 is asset inlining. So basically, what we do, we have an HTML pages, and in there we can directly inline some binary assets, such as pictures, for example. So we encode the pictures using base64, and it's directly embedded within the HTML pages. The problem is that it's base64, so it's not super efficient. And also, that pictures which is sent to the client will never hit the cache. So if you need that picture 2 times, you will have to send it 2 times. So use it, but with cautious. So we see that HTTP, which is a quite old protocol, has a lot of issue. And the fundamental issue is that we are using HTTP, which is a text-based protocol, on top of TCP. And if you look at those 2 protocols, they have very different goals. I mean, HTTP, it's basically a lot of small request response in a bursty mode. And TCP has been designed for long-lived connection. So there is a mismatch between those 2 protocols. And clearly, this is what HTTP 2 is trying to solve. So, HTTP 2. So first, HTTP 2 is now a standard. Not only that, it's 2 standards. So since a few weeks, I mean in May, we have 2 official RFC for HTTP 2 itself, so 7540, which is really the HTTP 2 specs. And there is another RFC that deals with header compression. 7541. So it's really now. I mean, it's really there. If we look in terms of browser support, so this is can I use? So this is that data comes from can I use? So it basically gives you what browsers support. For example, in this case HTTP2, but you can use that for WebSocket, SSC, and so on. So if you look at that snapshot, which is the one from this week, so basically, well, I would say all the browsers are now supporting HTTP2. The exception is Safari. So HTTP2 will be supported in the next version of Safari. And there's something a bit fishy around the IE. So Edge, the next version of, the new version of the Microsoft browser will support HTTP2. I'm not sure why it's greenish. I haven't checked exactly. But anyway, Edge will be released end of next month, so just 1 month away. So I think that if you make abstraction of Opera Mini, but I'm not sure who's using Opera Mini, and Android browser, I think that we can say that all the browsers support today or will support in a very short term HTTP2. So the main features of HTTP2. So HTTP 1.1, it's a text-based protocol. HTTP2 is a binary-based protocol. So that's a fundamental difference between the two. HTTP 1.1 doesn't support parallelism. We have some sort of pseudo-parallelism if we open multiple, if the client opens multiple connections. That's a kind of parallelism. HTTP2 provides real parallelism. I mean, over one single TCP connection, we can have multiple logical connections. That's baked in the protocol itself. So let's look at some of those in more details. But before that, I need to explain some terminologies. So HTTP2 has the notion of connections. So that's basically what we have today. It's just a TCP connection. The thing is that we just have one single TCP connection that we use. So we don't open multiple TCP connections. It has the notion of messages, so it's like what we have today. I mean, it's either a request or a response. HTTP has the notion of stream. A stream is basically a bidirectional channel that you have between the client and the browser. Those streams are broken into frames, into binary frames. So that means that over our physical connection, we can have multiple streams. These diagrams explain that in a more clear way, I think. So we have the connection, so that is the physical TCP connections. In there, we can have one or more streams. So in this case, we have two streams. We have a message flowing in, so to the client, from the client to the server, and from the server to the client. And those messages are basically broken into frames, binary frames. So there are different types of frames, headers frames, data frame, priority frames, and so on. I think the headers frames is the one that you will use the most, and the data frame as well. Now, I say that you will use those frames, but don't worry. I mean, you don't have to understand what are the different frames for. I mean, this is just happening at the network layer. That's something that you, developers, doesn't really need to understand. One of the nice things of HTTP 2 is that it basically preserves all the semantics we have today with HTTP 1.1. So this is an example of an HTTP 1.1 request. So this is a post request. We have some payload, some JSON payload. So if we look at, so from an application point of view, nothing will change. But if we look at what is being exchanged over the networks, so first the protocol will send headers frames that will include all the HTTP headers. And then another binary frames will be sent to basically send all the payload to the server. This is another example. So this is a simple get in HTTP 1.1. So in this case, one headers frames will be sent to the server. So we still have all the HTTP headers, and you see that, for example, this flag is set. So basically, this frame is closing that streams. Another example, so this is a post with some payloads. So in this case, we'll have two frames that will be sent. So the first one is the headers frames. We see that the hand streams flag is not set, so that means that upcoming frames are coming from that particular streams. And then we have data frames, and that one is closing the streams. Well, that one is the last frame of the streams. And obviously, it has the payload. So, so those two frames are binary frames. So it's not obviously not just for the data frames that we are using binary frames. Since the streams are broken into frames, we can interweave frames from different streams in both directions. So that means that we have true parallelism and real multiplexing. So we can have streams flowing in both directions at the same time. That is really something that is different than what we have today with HTTP 1.1. Because that is part of the protocol. We don't have to use any tricks to achieve that. Since we have multiple streams, it might be a good idea to set some priority on them. So the protocol defines the ability to attach priority information to the frames. And it's dynamic. It's not something that you set at the beginning and then you're done. That can be changed over time. So the idea, for example, if you are browsing to a website, it's a site that doesn't fit on the screens. So you're at the bottom of the pages, and the browser is asking to the server to send the picture that is at the bottom. But you scroll down directly. So that means that the picture that is being requested at the bottom, at the top, sorry, is not necessarily needed anymore. But it might be a good idea to boost up the speed, the priority of the pictures which is at the bottom, because that's the one that you will see very soon. So the protocol, the HTTP protocol, defines how to attach priority on headers. Oh, sorry, on streams. Now it's just an advice. So we can set priority, but it doesn't mean that the server will use that priority information. And anyway, the way the server might use the priority information that is attached is up to the implementation. So clearly, that's not something that is part of the protocol. So an example of priority. So, in this case, we have two streams. So, sorry, we have three streams. So stream B and C depends on stream A. And in this case, we are giving an advice to the server that in terms of resourcing you need to spend, well, you need to spend three times more resources to try to deliver the stream C than the stream B. So, and we can clearly set a hierarchy in the priority. Again, that's something that might be useful if you are developing backend applications. Something which is quite nice is server push. So that's a new capability that is baked in the HTTP protocol. It's not to replace WebSocket or SSE. This is something which is quite different. So the idea is that you have a web browser that is requesting a file, so index.html, for example. The server knows that to display that particular file, you will need the style sheet and the JavaScript file. So the server can decide proactively to push those files to the client before the client has asked those files. Because at this stage, the server knows that the client will need those files to render that pages, but that pages hasn't been sent to the client yet. So the client has no idea about those resources. So the server will send push promise frames to inform the client that he is about to push those files. So he will send a push promise frame for the style sheet, another one for the JavaScript file, and obviously at some point in time, the server will have to send the actual data which has been requested in the first place. So in this case, that would be the index.html file. And so the protocol says that clearly, if the server wants to push promise frames, it needs to do that before he answers. So before he sends the data streams that is corresponding to the original request. So this breaks a little bit what we used to have with HTTP. So as of today, HTTP 1.1, you do a request, you get a response. With server push, you do a request, and you might get one response or multiple responses. So the idea with that is that the server will be able to basically push payload to the client before the client has asked those resources. So that should reduce the latency, the overall latency. Now, clearly, this doesn't replace WebSocket. This doesn't replace SSE. On the client side, there is no JavaScript API to use that. So it's basically really, it's kind of doing a pseudo request from the client. So the client does one request, and the server will push multiple resources that might be asked by the client. Something else which is part of HTTP2 is hashpack. So this is the second standard that is part of the whole HTTP2 protocol. So it's based on a very basic idea. So if you look, when you use HTTP, when you do multiple requests, most of the time the headers doesn't change. So why bother sending again and again headers that doesn't change? So how hashpack works, the client and the server maintain a table with headers. So this is my first request. So I'm requesting pictures, which is at that path. So the client will send headers frames with all the information that is needed. Then I do a second request. I'm asking another pictures, which is located at new resources instead of resources. So clearly, most of the HTTP headers hasn't changed. So we don't need to send them again and again. So what will be sent? So the client, the browser, will send a new headers frame with just that HTTP headers. And not only that, we are not sending directly the information. We are sending, in fact, indexed to reduce the size. Very quickly, the switch to HTTP2 will not happen overnight. So HTTP 1.1 is here, and HTTP 1.1 will stay for the next 10 years maybe. So HTTP 2 can obviously coexist with HTTP 1.1. So if you have an HTTP 2 client, the HTTP 2 client can connect to an HTTP 1 server, and if that server supports HTTP 2, either the client will connect directly to HTTP 2, or it can upgrade the connection from HTTP 1.1 to HTTP 2. And this is done over, so this, if it's in clear, this is done using the HTTP 1.1 upgrade mechanism. And if it's over TLS, it's done using LPN. So this is quite efficient. So that was a very short overview of HTTP 2. I have a very basic demo that is trying to highlight the point, one of the benefits of HTTP 2. So, so you see, so let me show you. So this is an HTTP 2 connection. This one, well, it's over TLS, but I have a self-signed certificate, so that's why well, it shows red. And I can show you that it's HTTP 2 because I have this little plugin in Chrome that says that it's HTTP 2. So this is a static website. It runs on Jetty. It's one picture that is basically made of 256 pictures. So if, for example, I go here, I do open image in new tab. So I basically have a lot of small pictures to compose my big pictures. This is the same example running on the same Jetty instance. So I will load this one. So this is over HTTP 1.1. Yeah, something that I need to tell you. I need to disable the cache. So you see, well, it was fast, but I'm getting that from my local host. So if we look at the time, it took something like 1 second. If I do the same over HTTP 2, so HTTP 2 is there. And not only that, that is a TLS connection. So it's a secure connection. So that one has been loaded basically in, well, half the time. But this is not really fair because it's a local host. So it's a bit tricky to see things. So there is, on the internet, there is that, basically that same demo. On the back end, it's a Go application. So I will zoom a little bit. So this is going, well, this is going over the internet. So this is over HTTP 2. This is going over HTTP 1.1. So we see that, well, there is a difference in terms of speed, but it really depends on the network. So if I use this tool, so this is a very dangerous tool to use. So it's something that Apple provide to basically simulate bad network. And well, it's not dangerous, but when you use that tool, you need to make sure that you turn it off once you're done. No, but really. So it's on. I'm using, well, I have a 3G profile, so the bandwidth, downlink, uplink, no packet drop. So let's see. So this is the, can't remember if, so this is, yeah, this is the HTTP 1.1, and we'll load the HTTP 2. So you see that there is a difference. And not only that, the HTTP 2 is over a secure connection, and it has been started after the HTTP 1.1 download. And I mean, we can let's see, Edge. So HTTP 1.1 started, and HTTP 2. So you see that there is a big difference. Now, let me kill that guy. It's there. So this is, so the only benefit I've shown there is that basically we have, well, maybe I didn't show you that, in fact. So if you use the networking debugging tool, you see that this is all the requests. So we have the number of requests. So almost 300 requests have been done because there is the HTML5, the Java, there is the CSS, there is the Favico, and so on. So 300 connections done basically over one single TCP connection. And we see that, so basically this is when the connection, when the request is being sent to the server. Even if the server doesn't answer directly, I mean, this green means wait time, and the more you advance, the more you have to wait. But we see that at the end, it really works anyway, even if the server is not able to cope with that. And clearly, this is not something to do. To display one picture, you don't use 256 resources to display just one picture. But this is just to show the point. OK. So that's HTTP2. So we saw that HTTP2 will basically be in all the browser now or very soon. So what about Java? So there is a specific JEP, which is JEP 110, that is planning to introduce HTTP2 support to Java 9. Now it's a JEP, so the goal is to have that in Java 9, but as you know, we will only know if it will be there once Java 9 is feature freeze at the end of the year. So the goal of that JEP is to basically, well, if you look today, we have in Java SE HTTP URL connection. HTTP URL connection, I think, is there since JDK 1.1, and it's based on URL connection, which is there since 1.0. So it's a very old classes, and the issue with that classes, well, with those classes, is that they have been designed at that time with protocols and concepts that are not necessarily still relevant today. For example, URL connection, I think, support Gopher. Who is using Gopher today? Who knows what Gopher is? Okay. So that's the plus 40 years. So nevertheless, those classes are kind of very old, very rusty. They have a lot of undocumented parts. They are difficult to maintain, and so on. So the idea of that, basically, that JEP is to replace over time those classes. Not only that, it will obviously support HTTP 1.1 because HTTP 1.1 will stay for the next 5-10 years, and it will also support HTTP 2. I think it will also introduce support for WebSocket. So it should be easy to use. It's the first version, so it should cover the most common use case. So clearly, HTTP URL connection is quite old. It does quite a lot of stuff, so it's not sure that everything that you can do with HTTP URL connection, you will be able to do the equivalent in a more modern way with the first release of that one. And it has, obviously, synchronous capabilities and asynchronous capabilities. So this is some idea on how the API looks like. So I've just looked at the existing Java docs. So if you know JAX-RS, so who knows JAX-RS? JAX-RS client API. Okay, so it's very similar. So you see that it's a fairly easy to use and understand API. So we create the request and we do a send and we are done. Obviously, it supports post. So, for example, if you don't specify the get, well, if you don't specify an HTTP methods, by default it's a get. So that's what we have in the first at the top. You have obviously the ability to configure the request. So I have the ability to set in this case, the headers, for example. From a developer point of view, again, the fact that it's based on HTTP 1.1 or HTTP 2, it doesn't change. You still have that notion of HTTP headers and so on. So it's fairly transparent. So it has. So in this case, I'm using the send method. So this is a blocking call. It obviously has an asynchronous mode. So this is the send async method. So in this case, what we get in return is a completable features of Java EC 8. So it has the send async, and it also had a send multi method, which is also async. The send multi is basically a send method, an asynchronous send method that expects multiple responses. So typically that is for HTTP2. Now, if you use a send multi over HTTP 1.1, it will work, but obviously you will only get one responses. And again, this is using Java EC 8 completable features. So that's for Java EC. So Java EC 9, JEP 110 should introduce HTTP2 to the platform. Again, you might follow what is happening in that space, and if it's part of the feature freeze at the end of the year, it will be part of Java EC 9. Now, for Java EE, we will also introduce HTTP2 to Java EE 8. Now, if we look at those, so basically those are the main features of HTTP2. A lot of those, most of those features doesn't necessarily impact you as a developer. For example, the fact that we are using that the protocol is based on a binary framed protocol. I mean, from a developer point of view, it has no impact. Yes, at the end of the day, your application will likely be faster, but it doesn't really matter. So those are the features that will be exposed to the Java developer. This will be done in the Servlet API. So Servlet 4 will support HTTP2, and those features will be exposed through the API. So there will be a new priority class to basically get the priority information from the streams and set priority information on responses. So on HTTP Servlet request, we'll have the get priority method. On HTTP Servlet response, we'll have a set priority method. Obviously, for all the requests and response, we need to have the ability to get the stream ID. Something which is not clear to me at this stage is how the dependency will be exposed through the API. I've looked at the existing, the discussion that are happening in the EG, the Servlet 4 EG, and it's not clear. I know that it will be exposed, but I have no idea at this stage how it will be exposed. Something, obviously, which is very important for Java developer and web developers is the ability to use the server push. Because if you are developing a web application using GSF, using any kind of web framework, it would be nice if your web application, your web framework, has the ability to push in advance resources that will be needed by the client. So clearly, that is a big deal of Servlet 4, and that will be exposed through the Servlet API. Now, it's not clear how it will be exposed. So there are different proposals floating around. This is one of them. This is based on JT, Push Builder API. So if you take JT, I think JT 9.3 today. So JT supports already HTTP2. So the thing with the server push is that we need to have the ability from the backend side to set some of the HTTP headers, for example. Because you have to keep in mind that this is a response, but we don't really have there is an original request that has triggered those multiple responses, but for those multiple responses, we might have different HTTP headers attached than the one that we will attach to the main responses. So we need to have the ability to tweak that. So, in summary, HTTP2 addressed the limitation of HTTP 1.1. It improved the resource utilization, it increased the performance, it reduced the overall latency. It's compatible with HTTP 1.1. I've put compatible between quotes because it retains the semantics of HTTP 1.1. So as a web developers, nothing has changed. It defined the interaction with HTTP 1.1, so how you can upgrade from the connection between HTTP 1.1 to an HTTP 2 if it's supported. But clearly, there are things that you will have to keep in mind. For example, today, if you want to debug an HTTP connection, you can easily what is passing over the wire because it's a text-based protocol. You can still do that with HTTP2, but you need to use Wireshark, for example, those kind of tools. And also with HTTP2, something that you will have to do, you will basically have to undo all the tricks you have done in the past, such as asset inlining, image sprite, and so on. All those kind of tricks might have, at the end of the day, a negative impact if you keep using them over HTTP2. I put that TLS is not mandatory, so the protocol doesn't mandate to use TLS. Having said that, Chrome, Firefox will only support HTTP2 over TLS. I'm not sure about, well, I think that Safari will only support HTTP2 over TLS. And I don't know about the new Microsoft browser. But so, yes, it's not mandatory, but if most of the browsers only support HTTP over TLS, it will be kind of the de facto standards anyway. So HTTP2 and Java, JEP 110s bring HTTP2 to Java SE9, and Servlet 4 will bring HTTP2 to the Java platform. So in terms of planning for Servlet 4, that's part of the Java 8 train. So the AG has already started, and it should be finalized first half of 2017. And obviously, before that, we'll have reference implementation that you can use to play with. It's a planning, so it might change. But that's really the idea and the goal. So in terms of resources, the first one is the official spec site for HTTP2. So the spec is well, that's a nice spec. I mean, it's really pleasant to work. You can also do that O'Reilly.com URL. Check that one. That's basically a book which has been written by one of the Google guy. It has specific chapters on HTTP2. It's a very nice book. So, is there any questions on HTTP2? I will leave you the resources slides. Yes, I've heard some. Yes, you should maybe take the mic, or you shout and I will repeat the question. Yes. So the question. So I said that. So Java EE8 will support HTTP2. And Java SE9 will support HTTP2, and Java EE8 is based on SE8. That's correct. So, there is a trick there. So, for the servlet implementation, we are using some of the stuff that will be part of SE9. So, Servlet 4 will work on SE8 for sure. Yeah. Yes. Okay. So the difference. So the question is about what is the difference between WebSocket and HTTP2. That's a good and tricky question. So WebSocket is something that we have since quite a few years. It basically provides bidirectional communication over an HTTP-friendly protocol. So WebSocket, the handshake is done over HTTP. Right? So we have the handshake that is done over HTTP, and basically at the end of the handshake, if everything goes well, we upgrade the connection to a WebSocket connection. So at that point, we have a bidirectional channels between the client and the server. In HTTP2, so that means that WebSocket, if the connection is established, the server can push information at any time to the client. In HTTP2, once the connection is established, there is a channel between the two, but the server will never push information to the client, information that has not been requested. The only exception is when you have a push request. When you have a push request, it's not, well, the client has asked a request, and the server at that time can push information which is tied to that request. But other than that, it can't really push information in a completely asynchronous manner. So I would say that's the difference between the two. But we'll see, because over time, there might be some convergence between the two. So, yes?
How is HTTP2 getting around the Nagel problem?
The what?
The Nagel algorithm, slow start. How does it interact with that?
OK, so the question is, how does HTTP2 goes over the slow start issue?
Yeah, the Nagel algorithm.
We have the same issue. The only thing is that we only do that once. So if I go back to my demo, if we would have the ability to measure what time it takes to open that TCP connection that will be used, it will be pretty similar in both cases. But the thing is that if I take so this is the HTTP 1.1 demo, we have that slow startup time, 250x time. And that's clearly something that we want to avoid, because in terms of resources, that's a huge hit.
So the aim is to keep all of the streams literally packed as full as possible to keep the window open.
Yeah, and there's something else in the protocol. The protocol has some flow control capability and so on, but I didn't really talk about that because this is really going deeper in the network. Okay. Yes? So the question, do I know if Apache client support HTTP2? I don't know, but I assume that it will. Now, yeah, something I didn't mention. On the Java side of the world, because of some of the cipher suites which are imposed by the specification in HTTP2, HTTP2 will only work on Java EC 8 and plus. So I don't expect to see HTTP2 support on Java EC 7. Unless you break the spec and well, it won't work anyway. Yes? Yeah. Yeah, so the question is about, so in HTTP 1.1 we can do domain sharding to work around the issue. And clearly doing domain sharding in HTTP 2 is a bad idea. Because unless there is a strong reason why we want to get the resources from two different hosts, well, we don't have to. Because if we can still do that. But that would mean that we would have two socket connection open to two different hosts. So it's clearly something that if there is no compelling reason to do that, you should undo those kind of tricks. Yes?
What about scaling on the server side? Does it help the server, handle more users, more connections?
So the question is, what is the scaling impact on the server side? We expect that it should be easier to scale, because if I take my JT instance on HTTP2, I have one socket that is open on the server side that remains open, but it's just one socket. On the other hand, for this one, the server has to deal with almost 300 sockets. No, yeah. So the question is about the computation on the server side. There is one, because this is over TLS. But I mean, I mean, despite HTTP2, I think that we are all moving towards everything over TLS anyway. So, yes.
A question maybe. So with HTTP2, it seems it's going to be a more efficient use of the network itself, because you're going to have more packets coming in and out.
Yeah.
Is this going to be a problem for ISP, for internet providers? Are going to see an increase of network?
Okay, so the question is about what would be the impact for ISP over the HTTP2. That's a good question, because, for example, if the traffic is over TLS, it might be more challenging for them to cache stuff. So it's hard to answer, but there are some challenges. But on the other hand, mobile provider are keen to use HTTP2 because if they can work around that issue of TLS, so if they can be the man in the middle, they would have the ability to cache more stuff and push stuff proactively to their client. And yeah, something I didn't mention, if you have a server that is pushing you resources, so you do one request, the server send you push promise, the client has always the ability to decline those resources. Because it might be that the resources that the server is proactively trying to push is already in the cache.
Is there any tricks going on at the hood at native level?
Sorry?
Is there any tricks going on at the hood, like Unix, Linux, select calls to bring about the HTTP2? Are they doing anything advantage of something new in the implementation of Servlet?
So the question is there any tricks really at the operating system level to get benefit of HTTP2? I would say that it's something that is implementation specific. So I assume that over time we will have those kind of optimization, but it's really early days. So we still have 1 minute. No? Well, if there is no more question, enjoy the rest of DevOps, and thank you.